Hello, everybody. We're going to talk a little bit
Hello.
about electrical systems in mobile vehicles, RVs, solar, batteries, DC to DC converters, all sorts of exciting stuff. My name is Mitchell. We're with Victron Energy.
I'm
Justin here. Here, I'll pass the mic over.
Justin, also with Victron. Got the shirt on. You can see that already.
Very official.
My colleague and I are sales managers for Victron, so we're responsible for all the sales that go on in North America. So that's in the U.S. and Canada. That's distributors, dealers, DIYers. So just listening to that, I'm sure you can tell that we're busy folks here. But what we're going to do today, as my colleague was mentioning, is talk about some system design. So batteries, battery monitoring, that's important. Solar chargers, charging from your alternator, which is pretty popular. And also some DC conversion if you had, let's say, a 24-volt system and you wanted to power some 12-volt loads. So I guess to start off here, all of the stuff that we sell is power conversion electronics, and it all centers around batteries. So whether that's lead batteries or lithium batteries, that's an internal BMS or an external BMS battery. And that's where it all starts here. So what you generally start with is a load survey. I call it a load survey. So you get like an Excel sheet out or a piece of paper, and you make a list of all the things that are inside of your van. So let's think refrigeration, lighting, air conditioning maybe, some other items that you could think of.
How much do you use the microwave?
Yeah, microwave, a hot pot perhaps. That could be another refrigerator, yes.
Slow cooker. All
A
those
slow
little
cooker,
things.
yeah. All the things, all the creature comforts. So people come up to us often and they say, okay, well, how many batteries do I need? Well, we don't know that until you tell us exactly what you're trying to power. I often get the answer to that of all the normal stuff. Well, that's a pretty tough one there. Because you could have no microwave, you could have a microwave, air conditioner, no air conditioner.
If the air conditioner is included, that makes a big difference. It's like 3 times the size of a battery you're going to need just to run the air conditioner.
Yeah.
Everything else can be considered within just an hour or two use a day, usually a fairly small amount, but 1,500 watts to run an air conditioner even for 2 hours is going to drain 200 amp hours, something like that, significant amount of power.
Yeah,
But yeah, the battery is kind of the heart of the system. It's kind of where everything comes back to and comes out of as far as the energy. Should we start with production?
Yeah, we can certainly talk about solar. I know that you have extensive knowledge on the types of solar panels. Perhaps you could speak to that.
Yeah, so solar panels on RVs are super helpful. If you're camping somewhere for a while, solar is going to passively, consistently bring power into your system, especially if you're not parked under a tree. So there's several different panel types. You have polycrystalline, that's the original type of solar panel, which is basically taking silicon crystals and we're smashing them up and smashing them into a little wafer. And we put those into, connect them together in series. Each wafer produces a little bit of voltage, about 1.5 volts. And as we add them together, we get up to about 18 to 20 volts, which is what we produce in a normal panel. And then monocrystalline, moving on to the different types of chemistry. Monocrystalline is a perfectly grown single crystal that is, I think, 20 feet long, and then they slice it into wafers. But the process is really incredible. But the single crystalline structure has far less resistance, so energy is able to flow through it without having loss, and so it's more efficient by, I think, around 10 to 20%, something like that. And then we also have flexible panels, which is the more modern style panels. Mm-hmm. So monocrystalline and polycrystalline panels, poly's kind of old school, but those are going to be glass panels. They're going to last 20, 30 years. They'll actually last a lot longer than that if you just keep them clean and let them run. Flexible panels, though, have a lifespan of around 2 to 5 years, generally speaking. Some of them are more like 10 to 20. It depends on how they're mounted and how well, the material that you use. There's a paint-on solar panel as well. But that kind of covers the various panel types.
Yeah. One thing to add there, I'm not sure if you agree with this, but I'm going to say it. A long time ago, in years past, there was a big difference between the power production of a solid solar panel and a flexible solar panel. Well, that gap is closed now. They're much closer. We actually tested this on our previous training trailer. We had one row of flexible solar panels on one solar charge controller. We had a second row of solar panels that were rigid on a second solar charge controller. And the production was really close. It wasn't always like that up until, a handful of years ago.
Yeah, well, a lot of the time with the sun power cells, which are the monocrystalline cells, it would work well. You'd have high production for like 1 year, and then it would drop off to literally 50%. So you may get a little bit of good use out of them, but then they just drop off. So if you get solar panels, flexibles, they could work well for a couple of years, and then a couple of them are going to start to drop out. And I know this because I used to replace them for a living. That's what I did. So, but yeah, one other thing to mention is the panel arrangement. So you can put panels in series or parallel. There's no real advantage over one or over the other with an RV in general. When you parallel them, you have to have a larger wire because you're carrying a lot more current. And so you have to have bigger wires coming down to your controller. When you series them, you have to have a controller that can handle the adequate voltage. So as you add the panels together, each time you add 2 together, you 20, 40, now you've got 5 of them and make 100. So if you've got 10 panels, 200 volts is a lot of voltage. So you also have to consider, do I want 200 volts coming down that I might shock myself on? So
probably not.
So yeah, I like to parallel panels when possible. And if you have a really big array, series parallel them. But again, there's really not a major advantage. There's been a big argument about whether series or parallel is better. This may be the case in some applications, larger arrays, for example. But for RVs, we're converting that to DC, which is a MPPT solar charger versus a household solar charger, which is an AC coupled. So,
the only advantage I could see for series connection, so think about the sun coming up. Everybody saw it this morning, or maybe you didn't because you were sleeping in from a late night last night. So when the sun comes up, it takes a while for it to get into the sky. And what does that mean for the solar charger and the solar panels? If you have them in series, then the voltage, the initial voltage when the sun starts coming up is higher. That means that you start charging earlier in the day. That also works when the sun's going down over the horizon. You charge later in the day. So you're actually expanding your charging time during the day if you put them in series. But partial shading from trees or stay wires or whatnot also has more of an effect on the solar series connected array. So
if you're parked
it's kind of a give and a take there,
You're parked under some trees, it might be better in parallel, but again, it's hard to tell. With the new charge controllers, the solar tracking actually will pick which panel it doesn't need to charge from and essentially adjust the voltage. So it's very quickly taking care of which panels are in the shade and which ones are not. You had a question?
Yeah.
Is one type of panel more resistant to damage from hail and walnuts?
Foreign objects flying onto the panel. Yes.
Generally speaking, it's just about size, I think. For mobile applications, and I can speak to this a lot because I put 300-watt solar panels and 400 watts on roofs, and they work. But when you have like a 200-watt solar panel is kind of the maximum size I'd recommend. As far as the brands go, you can probably get a cheap panel that's got lower quality glass, but all of them are tempered, very durable. And my customers in the past have come to me saying, we were in a hailstorm. Every part of our roof that didn't have a panel on it got damaged, and the panels were fine. Yeah.
Well, I was just thinking about his question, and maybe you can speak to this, just about mechanical construction. I would think that a larger surface area would be more subject to damage because there's not so much support in the middle of it. Have you had any experience with that?
That's what I was getting at. Yeah, so the larger panels are more vulnerable, not so much to hail damage, but to road damage. So the 400s can break, I think, but I haven't seen it. Like, in general, I haven't seen a lot of applications where people are using these larger panels, but 200s is usually my maximum recommended for RVs, just for safety. Mounting as well, wind, that becomes a sail pretty quickly.
Real estate, because you have all sorts of things on the top of your RV, and there's not always room for a large square footage of single solar panels.
So far, that's not an issue.
Yeah.
Okay.
Yeah, good question. Any other questions? Feel free to interrupt. Put your hand up. Happy to answer those.
Walkable panels, is that walkable?
Walkable?
Walkable panels, that's a good question. So when it comes to walkable panels, I think flexibles are the best, and that is that paint-on style. There's one brand I mention is Merlin. They make there's another one that's Marine brand, which is a little more durable, I think. But I think Merlin also is maybe the equal quality. But they have a textured surface, so it's non-slip. They've got little, it's like prisms actually built into the surface texture, which helps the light get captured, which is very interesting. So a little bit of advanced technology going into that. But they're flexible, completely walkable. Yeah. And they lay flat.
And they're durable still as well as
for
the hail or whatever
that will
come at it?
That's a good question. I don't know about hail resistance on those. It might be there would be more vulnerable than glass, in my opinion.
Yeah, I would imagine, because they're squishy almost.
Yeah, I would say they're probably just as strong as the roof. And I think if you were to get hail damage, it would maybe not knock out production, but reduce it. But they probably do okay.
It's okay. Yeah, not to interrupt you. And it's okay to lose a cell in a solar panel. That's something I get a question on a lot. Previous years, so I explained this like Christmas lights. Everybody's seen Christmas lights growing up when you were a kid. You have one bulb, yeah, so you're going the right way here. If you take one bulb out, the whole string stops working. And solar panels used to be like that, not anymore. It's like the modern Christmas lights. If you take one bulb out, the rest of them keep working. So that's exactly the same with the cells and the solar panel. That's a great point.
Yeah. The one
Got a
point.
question?
Yeah. Go ahead.
Do they sell a polycarbonate paint you could paint over where you had hail damage on these?
You mean in the glass?
Well, in the walkables.
On the walkables?
Ah, yeah, yeah.
There's a layer on top of the solar cell itself, so there wouldn't be a way to repair it or add to it. It's kind of a one and done thing. They have like it's painted on and there's multiple layers, I believe, and then they have a coating for the or an external surface.
Maybe after a hail damage here in Colorado, you could buy some liquid.
Yeah, to patch it up.
I mean, as long as something to patch it from liquid damaging it, because once water gets in, it will start to erode or oxidize the metal. So I've definitely done that on the back of a glass solar panel where it's been damaged from a stick or something, and then you just put a little bit of sealant on it, and then you can preserve the panel. So yeah.
There was a question over here about bifacial panels.
Oh yeah.
What was your question? What about it? What's the deal? Yeah.
Bifacials can be more efficient. I've definitely seen them more efficient in freestanding.
Yeah, me as well. I've seen them more efficient on boats, right? So you can hang them over the davit in the back. So there's like a canopy in the back of the boat. I've seen people put them on slides so they can slide out over the ocean. And the amount of reflection off of the water, everybody's had a sunburn on the water probably, is incredible. So yeah, the production is significantly more if you can expose the bottom side appropriately.
I've had a customer that did do bifacials before, and they said that they produced like 10% more on the RV, but they tried to gap them out, which is like then you're sacrificing some of your road efficiency, driving efficiency.
You're driving a parachute down there.
One thing I was going to mention before about the flexibles, the walkable panels, if you have a glass panel and you've got a gap, you always want to have a little bit of a gap there. You're creating an air gap and you're creating a little bit of an insulation, an insulator. So it actually adds to your air conditioning. Having panels covering your roof can drop the temperature depending on how good your insulation is in the roof, but it definitely helps. And having walkable, flexible panels, there's two things about this. It does saturate the roof for heat, which is going to reduce, you're going to produce more heat within the RV, but it also damages fiberglass. I've seen it happen multiple times.
Underneath the panel.
Yeah, I've seen it on more often than not on systems when I pulled panels up. There are big cracks going right down because of the amount of heat that's being saturated into the roof. So I don't want to speak negatively about flexibles, but I've had bad experiences with them. And yeah, if you can gap the space, then you're not going to saturate your roof with as much heat and not damage it as easily.
Yeah, okay. Yeah, nice.
Yeah.
Question in the back.
When designing a system, how do you choose between 12, 24, 48?
Good question. So 12 volts works for up to 3,000 watts of inverting power. You can go 24 or 48. It's kind of preference. But as far as we're concerned, once you get above 3,000 watts, it is optional to go to 24 volts. If you're at 5,000 watts, I'd recommend 24 volts. 10,000 watts and above, 48 volts, generally speaking.
With that being said, we do make a 5 kilowatt unit that's 12 volts, but yeah, that's really at the upper limit of it.
Right.
You're running DC cables that are the size of your wrist at that point.
You have to run two of them too,
Yeah,
double.
it's not fun. So you got your knee on it. You're trying to get around the corner. It's it's not a lot of fun.
Yeah.
Can I ask a question about the certification?
Certifications.
Yeah, electrical certification. Once you got your unit in, how do you get that certified? For whatever insurance company might throw at you.
You have some experience with this? Yeah.
Well, that's a good question. I've definitely dealt with some insurance companies. We did electrical installs, and my company would insure our own installation work. As far as getting insurance coverage from your company, it's really just a matter of adding it on. Because once you have a system installed, they will include it in the insurance. If there's an audit and they are suspicious, then they might look at it differently. But I've never had any audits rejected due to fire damage issues. I mean, fire happens occasionally, but I've never had none of our systems catch on fire, thankfully.
That's a very important point here. There are lots of people in the industry that are installing these things. I need to be careful here. That aren't fully capable of doing so they can create dangerous situations. Yes, question?
So we just had plug-in solar approved. Wall was approved just several months ago here in Colorado.
Plug-in solar, yeah.
Can you guys talk anything about that? Do you have any electronics like the microinverters or anything that allow that to happen?
Plug-in solar. More context. Plugging into what? Where is it?
Okay, so plug-in solar.
Residential.
It's basically allows, it started in Europe, and it allows people who maybe don't own a house, either an apartment or something like that, they can hang these panels, say from a patio or something like that, outside up in the air. At home, you can do a small batch of panels up to 1920 watts. And what you do is you have them connected to a microinverter, and then you plug it right into your 110 volt. You don't have to get any approvals. It's as long as it conforms to the regulations by the electric the power companies. And so what it is it takes away the barrier of entry for people getting solar and having to buy all this equipment and get all the approvals.
I understand.
You can plug it in and go. And so it's approved now. The law was signed 2 or 3 months ago.
I don't have any experience with that
neither
myself.
do I. We
Yeah.
don't make
I
microinverters.
I looked into it briefly, but
We're
Well, we
pretty
do-
busy boys already.
we do DC coupled. So there are two markets for solar and energy, essentially. So there's AC coupled, which is households. That's basically your solar panels are coming in at around 240 volts. The inverter just makes it AC, and it sends it out at 240 volts.
Yeah.
Our systems take in anywhere from 20 to 250, and then we produce DC voltage, 12 to 48 volts. So our systems are for mobile power backup systems. We run various kind of UPSs as well, so that kind of thing. Yep.
Yeah, so to answer your question, we already have a solution for that, but not exactly what you're describing.
Yeah, it's just another level of electronics to allow you to do that.
Yeah. So we would have 901 SKUs instead of 900. Yeah. Question?
Yeah, I'm looking for a small foldable solar panel about this big that I can use to charge my phone when I'm hiking.
Yeah.
Put it on your backpack. It's about that big. You fold it
Have
up.
you ever seen anything like
I
that?
have one. It's great.
have
I don't know what brand it is though.
Yeah, you can get them at REI.
Yeah, I think
REI.
I got mine at REI actually. Yeah.
Yeah, we do.
Yeah, we do. I could probably help you look it
Yeah,
up
come
later,
see
but I
us.
don't know
We'll
any brand.
talk about that
Yeah,
separately.
yeah.
Where's
we're-
the trailer? That's a great question. Up here on top of the hill. I hope you brought your hiking shoes.
When you find the white geodesic dome, we're just up
Yeah,
the
we're
hill
right
from there,
behind the van
that.
life tent here. So if you look right at that tent and take a direct
Oh, yeah,
right,
right there.
we're up on the hill.
Direction.
Come see us.
Yeah.
Yes.
The rumor mill is you're going to update the new Orion XS to be bi-directional.
Bi-directional.
It's so yeah. I was fighting for bidirectional,
It's
but
not.
it's going to
No.
be a boost capability, and this is essentially going to allow if your engine battery won't start, you can hit a button. It'll surge the full capacity backwards and charge the engine battery, so you can
Enough
start
to
the
get the
engine.
engine started. Yes.
Yeah.
Ooh,
No.
Not yet. No, there's not a date, and if I told you a date, you would be in my inbox the day after.
Give us the specs. Is that a 50 amp or what is that?
The DC to DC charger?
Yeah, the Orion XS. So the Orion XS is a 1212. Yeah. So
They can't hear the questions.
what is the volt?
Okay.
The amperage? What does an Orion XS do? What's the amperage that it charges at? So the Orion XS is a DC to DC converter, and I was actually thinking about jumping into these next anyway. So that takes power from your alternator and charges your house battery. You used to just have an isolator that would combine the two systems, just connect the two batteries. But due to lithium batteries being able to consume so much energy and hold a stable voltage, and also modern vehicles not wanting to damage the alternators, they have kind of more or less outlawed the use of them. So Mercedes will only allow DC to DC converters now with a maximum of 80 amps to charge. So the Orion XS is a 50 amp charger. It's a 12 to 12 DC to DC charger. We also have a 1400 watt version, which is also 50 amps, but that does 12, 24, 24, 12, 12, 24, 24. It does any combination. So those allow for alternator charging at a regulated value. You can say, I only want to draw this much energy from my alternator and charge my house system. But yeah, 50 amps and DC to DC.
70.
Yeah.
So as of yesterday, there's a 70 amp model of the Orion XS. That's very new. Yeah, I know. You just bought the 50. Now you want the 70, right?
No, I don't want
No, you don't want the 70. All right. Yeah. So not only current limitation on the DC to DC chargers for everybody, it's also changing the charging voltage algorithm for lithium because the factory alternators are not set up for that. So you're doing two things to protect the alternator. One, limiting the current. That's a good point. I usually say 50% of the alternator's output. So if you had 100 amps, that's 50 or?
Yeah, the smaller your alternator is, the less energy you get out of it. About 50% of the
Yeah.
alternator is usable, generally speaking.
So that question comes up a lot. I want to charge for my alternator. What do I need? the first question we're going to ask you is how big is your alternator in amps? Because we want to limit that to about 50% of its output to not overheat the alternator. Many of you have probably had your hoods open or know what an alternator is, but it's mechanically cooled by the fins that spin right behind the pulley on the belt. And if you don't limit the output of the alternator, it will produce as much as it can, even at idle. And when it's mechanically cooled like that, well, that's the worst possible scenario for an alternator, because it's the least amount of cooling while it's putting out the most amount of current. And that's when you see the smoke come out of the hood. You don't want to see that. So yeah, generally recommend 50% of that when sizing those.
And you want an alternator that's at least 120 amps. I usually recommend 160 amp alternator minimum to charge from. If you have a 60, no way. Does that cover anything else on the DC to DC?
Yeah, I
Any
think
questions
so.
on DC to DC?
You can parallel
converters?
those if you want, but generally by the time you're paralleling those, you're talking about secondary alternator and something like a wake speed. Or yeah, you have a question? Two questions.
Yeah, the DC charger,
Yes.
is that preset at the factory for a particular charging current? Or can I decide to change the setting later on in the life of the system?
I'm going to repeat your question for the folks that can't hear over here.
That's fine.
Yeah, I know. I see the fingers. I got you. The DC to DC charger. His question was, is it preset from the factory for a specific amperage? That was one of them. Yes?
No,
Yes?
that's it. That's
Yes, it is. It's set at its maximum
So I
capacity.
can't change it.
You can change it. Yes.
Can change it.
On the Orion XS, you can change it. You cannot change it on the 30 amp models that we have, the previous models. But going forward from those, the 50 and the 70, you can adjust it up and down in 1 amp increments between 0 and 50 or 0 and 70. Yes.
To add on to that,
Thank you.
real quick to add to that, every one of our Orions will automatically derate itself, so it'll only draw what it can from the alternator.
Great.
Go ahead.
And as I'm familiar with Toyota hybrids, I have 2 of them. I've never had a Sienna hybrid, but Toyota seems to really have it down. But are you seeing other car manufacturers kind of screw it up and eventually act like Toyota? And do you, because their hybrids don't have an alternator, yet you can still kind of use it. Maybe it's not sanctioned by the manufacturer. Still kind of
Yeah.
use it.
Want to
So
repeat the
I know
question?
officially you
Yeah.
have to probably say no, but unofficially people are utilizing this.
You will never
Yeah.
hear us talk about unofficially in a group setting like this. Let's start there.
Yeah, so the question was, so Toyota has some of the best alternator connections capabilities, and are the other brands going to follow? Is that pretty much the question as far as connecting a DC to DC converter and the accommodations
to be
for it?
safer. Are
Yeah.
they going to make their hybrids or to be safe?
As far as the hybrids and the EVs go, it's kind of a free-for-all. We don't have a good answer because I've seen some that do it very well and others that don't know what they're doing. I have a Rivian, and my power system is, I've got a 10 amp, 12 volt system, but there's not much back and forth, so they don't have much accommodations for the DC side of things. And a lot of EVs are like that, I suppose. But I think that's going to change, and I don't know when and exactly what that'll look like, but it's kind of coming together, just like the bidirectional AC with EVs it's been like we've all been waiting for it, we've all been talking about it, it's finally starting to come out, but all of the jurisdictions, electrical companies have to kind of get behind it as well, so we'll see how it develops.
Yeah, good question. Any others on that? Right, yeah, if you want to see some of those converters, come over to our trailer again, take a right at the dome, go up over the hill. We've got them sitting there on the bench. I think you'd be quite impressed how small they are physically,
Yeah.
how they
Oh.
don't have heat sinks, and the
Ooh.
efficiency of them.
I get excited
He's
talking
been
about this.
touting the efficiency here, so maybe
So,
we can talk
okay,
about that.
so-
Why would you buy a blue one instead of another color?
This will be the last thing about converters, and then we'll move on. So DC to DC converters, as long as they've been around, are roughly maximum of 88% efficiency. You can't get above 88%. That's the amount of energy that is lost. 12% is lost in converting that energy
to heat. It gets hot.
Lost
That's
in
why
heat,
it gets
yeah.
hot. This is
So,
efficiency.
Converter, a lot of converters, you put it under your seat in your van, or this is an example, your seat's going to get pretty hot. The converter might derate itself. It might not be able to charge at its maximum output because of that. Our new Orion XS, the reason it's so small is, and the heatsink is just a flat piece of metal, is it's 98.6% efficient. That's more than 6 times less heat lost. I would like to say more than 6 times more efficient, but we're just talking about the remainder here. So it goes from 88 to 98.6. So
good.
that means you can put it under your
Nobody
seat
else.
and you won't even feel it get warm.
Nobody else is even remotely close to that. That's a technical reason, and I like to explain technically why you would choose a blue product over another brand. Nobody is within 10% of us on that, and that's a big number.
Yep. we're using resonant switching technology, but I won't bore you guys with the cool technical stuff on that side. So why don't we jump into inverter chargers and talk about how the AC power system passes through an RV?
Let's ask the crowd. What do you
Okay.
have? Do you folks have just inverters and chargers, or do you have inverter chargers, or a mix of both? Okay, raise your hand if you just have an inverter with no charger inside. No? Okay, nobody has an inverter. Huh? One person? No? Yeah, perfect.
Saw two.
Two?
Three.
Oh, hi.
Hey.
Yeah.
Yeah, right.
So you can do both. You can have a separate inverter and a separate charger. I've seen that go both ways. What are the advantages of doing that? Why would you do that, Mitchell? Why would you choose
Well-
an inverter separately from a charger?
Man, I'm usually talking about the advantages the other direction.
Okay, well then I can
Yeah,
talk about it. Yeah, well the number one thing that I see is people traveling around, so different voltages, particularly if you're going into South America or you're shipping your van across the ocean into Europe. An inverter charger, you generally have to choose whether it's 120 volts, so that's what you have on the counter at your house or in your van, that's the 3 prongs that you see for the coffee machine. Or 230 volts, that's the native European voltage. I know plenty of customers travel into Europe with their vans. Or you have a third one, that's 120, 240. Many of you seen the dryer plug in your house, I guess. You pulled it out to clean the lint out, maybe even seen the plug come out. There are 4 prongs in that, so you're dealing with 3 different types of power if you're traveling around. And well, it becomes complicated using an inverter charger for that. It's not impossible, of course, but it is much simpler to use a wide input voltage charger, so that way it can accommodate all of the places that you're going without having to do all sorts of adapters and well, all the things that you probably dealt with here. So that's one of the main reasons that I see. Also the frequency, if you're going into Europe or any place that produces 50 hertz instead of 60 like we have here in the US.
You could have different power coming in than what you are producing and using inside the vehicle.
Exactly. So if you're a traveling soul, so traveling outside of the US and Canada, you might consider using a battery charger and a separate inverter for that reason. It really simplifies the ability to accept the voltage, the native voltage where you are, and also the frequency that's coming out of the grid. That's a big reason to do that. That way you can have a separate inverter to produce whatever you want inside of your installation. So you're putting it into the battery with the charger, and you're taking it back out with the inverter to produce exactly what you want inside of your installation to power your AC appliances. Yes, question?
I've had an issue where my battery bank is depleting, I think, too quickly. And people have looked at the load what I'm using, which I don't think is much.
Yeah.
But the advice I've been given, I don't know if it's good advice, is when not in use, shut the inverter off.
Yeah.
Mine is a combined, it's not separate.
Yeah.
It's a Combi Master from Astronaut.
Yeah. Yeah.
Does it make sense to do that, turn the power off?
I'm going to repeat your question before I answer it for the folks in the back. Big fans over here. Yes, I see you. The question is, my battery bank is going empty sooner than I'd like. Should I be turning the inverter off when I'm not using it? Yes? I would. All inverters, whether it's us or anybody else, have standby consumption. So that's a parasitic load. That's another word for it, parasitic load on your batteries. And for me, if I'm boondocking like this, it doesn't make any sense to have anything on that's draining my batteries that's not completely necessary. And other brands, not using names here today because that's not what I do, have much higher zero load power or parasitic draw than we do. So that's another reason to look at a blue one rather than whatever other color. Yeah, so absolutely, I would switch my inverter off if I wasn't using it. Yes.
Follow-up to that is, now I want to charge these batteries. Inverter on, inverter off.
Now I want to charge my batteries. Should I turn the inverter on or back off? I can only speak to Victron for that. Maybe Mitchell has some experience on the other ones, but if you don't have our unit on, then you can't charge with it. So you have to turn it on for that, even though you're not inverting with it. If it's a combi unit, an inverter charger has to be on, and that way you're charging into the battery, also passing through at the same time to the outlets.
Well, in ours, the charger only mode can be used to preserve. So yeah, if you do lose shore power, for example, and this is really good practice for storage. If you've got your inverter in charger only mode, it will pass through AC power, it'll charge the battery, run your AC loads. But as soon as you lose shore power, the power goes out, the inverter is going to shut down and just go into a silent mode. So you're going to preserve whatever battery is left, and at that point you might be just running DC loads, which is going to last a lot longer.
To expand upon that, we have 3 switch settings on our inverter chargers. That's a combi unit from Victron. The green one, I don't know. what those guys are up to. But yeah, so there's three positions. There's an on position, which means that the unit can invert from the battery bank when you're not plugged into the shore power. That's what you're describing, killing the battery. It will also consume power when it's just sitting there and you're not running anything, which you don't want, and well, most people don't, because you have a finite battery bank, right? But what Mitchell's describing is a second position called charger only. So we can go on, off, or charger only. And charger only does exactly what you want and what I would want in my case. When I plug in, charges my batteries and powers my outlets in my camper. But as soon as I unplug the shore power cord, it switches off as though you switched it off. And it just waits until you plug it back in, and it doesn't consume power when it's doing that. So that's probably the move if I were using a Victron, yeah.
As far as I know, I think on my Combo Master, it's just one on-off.
Okay, so you just have an on and
When
off.
I power it down, I think I'm losing the charging in.
Okay.
Converting.
Yeah, okay. Well, come see us in the blue tent.
That's what
We
I-
got that.
That's where we're headed, I think.
Yeah.
So
yeah.
we talked about converters and inverters being separated, and now we can talk about kind of the benefits of them to being together.
Combination unit, like you're
the
discussing.
inverter charger. So that's pretty much all of what we sell these days are inverter chargers. Most of our inverters are in smaller units for, truck campers and that kind of smaller application. But inverter chargers have a couple advantages. First off, they are a transfer switch. It allows power to come through from multiple sources. If you have one of our Quattros, the Multipluses have a single input. Our Quattros basically could have a generator coming in separate from shore power. They will automatically regulate how much charging you're doing using a tool called the current limiter. So when you plug into a new power source with one of our inverters, you want to say, okay, I'm plugging into 15. You want to go up to your system and set it to 15. The current
Specifically,
limiter.
so to be clear here, when he says 15, that's a 15 amp breaker on the pedestal.
Yeah,
So you
yeah.
pulled up into a campground, you see the pedestal, there's a weatherproof cover, you flip it up, it says 15A on it. That's what we're discussing here.
Yeah. So yeah, 15 amp breaker or 30 amp breaker. You just want to match that to your breaker size or your current limiter to the breaker size you're connected to. What that does is allows the charger to use as much of that energy that you're not using to put in the batteries. But if you want to cook on the air conditioner and start consuming some of that AC power that's available, you're going to be able to do that without overloading the system. The charger is going to reduce, and even to the point where our system has load assist capabilities, and that's the second aspect of inverter chargers. Hybrid inverter chargers is what the typical name is, what they're called. It can load assist, so you can bring in AC, bringing in 15 amps, and then let's say you're consuming 30 amps of energy. The inverter can actually produce the other 15 amps from the battery, and as your loads are varying, whether they're above or below your actual power source, the inverter will flow between those states naturally. It'll go from charging, load assisting, and meanwhile your breaker's not going to pop. The system's going to allow you to run more energy than what you have available at the power source.
Yeah, so middle of the night when you're pulling in off the road and you take the shore power cord out and you plug it in, and then you start turning on the air conditioner and all the things that you want to do, cool off the van when you're plugged in. If you didn't tell the unit, our unit, I'm speaking of Victron, how big the breaker was on the pedestal that you're plugging into, it doesn't know. So it could take more than the breaker is capable of delivering, and then you trip the breaker on the pedestal. And this, of course, is 11 o'clock at night. You didn't bring your flashlight. Everything's in the dark. So yeah, that's a unique feature of Victron, is to be able to program the AC input current limit so it knows exactly how many amps it's allowed to take from the pedestal that you're plugged into. You can move that number up and down so that way you never blow the breaker on the pedestal. Is another way to explain that. Any questions about that?
How accessible would that be to change?
How accessible is that? That's a great question. You can do it with a computer if you're just putting the inverter charger in by itself, but in a mobile setup, I would always recommend using some type of remote panel, and all of our remote panels have that capability, whether it's a very simple one that has a little dial knob on it with an LED display. We still sell a ton of those. Very popular for people that don't want to play with all the technological things. They just want to grab a hold of something and say, okay, this is the number, right? So we have a simple panel for that, and then we have some fancier options with a touchscreen, which you can do it from as well. But you would need some type of remote panel, and I would always install one in a mobile application. That's not a salesy thing, that's a functionality thing, because you want to be able to move that up and down between 15 and 30, depending on where you're plugged in. Whether you're at the in-laws house, it's 15, you go to the campground, you have 30. So you want that dynamic ability to move it around. Yeah, so with a remote panel, to answer your question. It's a good question. Thank you. Any others?
Does the surplus power that you're creating go back into the grid when you're plugged in?
No,
Like
you're
it
actually
would in
not
a house, you know?
surplus from the solar, you mean? That's another
Yeah,
question?
yeah.
Okay, so not the
Sorry.
inverter charger.
Thank you for-
So the question is surplus energy going back into the grid? And yeah, no, it is not. Our systems are isolated from the grid. We can consume power from the grid, but that's all we can do is one directional, essentially, yeah. And our systems, our equipment is
Yeah.
capable of bidirectional energy flow, so it can backfeed to the grid. We have it disabled for the legal reasons in the U.S.
Yeah, also safety reasons,
Safety
to add on to that. So you have this little cover on the outside of your RV that you plug your shore power cord into. If we allowed that to happen, you would flip that cover up, and if you slip your finger in there, you get electrocuted. You don't want that. We don't want that. That's like the McDonald's lawsuit for the hot coffee, you know? We're not doing that.
Well, I've got one more for
Yeah.
inverters. So there's one thing that we do very well. There's only one other brand that I know of that produces an inverter that is capable of connecting to 50 amp service with a single inverter. There are dual phase inverters and other grid tied inverters, but in the mobile application world, we've got an inverter that can switch between connecting to 30, 15, which is single phase, and then up to 50, which is dual phase. As I was saying earlier, this is up to 4 prongs and 2 conductors.
Your dryer plug in your house, that's the 50 amp 120 240.
And so inside that inverter is a mechanism that's choosing how to pass that power through. And what it does is allows you to have the full usable power within the system on both legs with load assisting capabilities. I was saying you can bring energy from the batteries and add to the AC power. And that's something we're doing. That inverter is called the 2X120. So those are in 3 and 5K.
If you want to talk about that, come see us at the trailer. We won't bore everybody in the group. Yes, question?
Yes, as we get more into EVs, I don't have one yet, I just have a PHEV, but, in people trying to, charge their cars and DC it,
Oh, that's me.
Oh.
what do you anticipate for that? Just putting one of these 50 amp plugs in, or do you think it'll go higher for EV charging at home, for DC?
DC.
Fast charging.
The question is
Like for
really...
residents?
Yeah, so the question was as far as RVs and EVs being able to charge DC fast charging at home.
In the
Right.
future, like
In the future.
planning for the future. if you're-
So I could speak to this. I've got an EV and I've done electrical stuff for quite a while. I in my experience, DC charging, really high speed charging, and I should back up. So you've got your standard 15 amp or up to 50 amp level 1 and 2, which charges at a trickle essentially. I mean, I could charge at my house. My truck can charge up in like 10 to 12 hours, which takes a long time. But that's the highest speed you can get at home. For like a smaller vehicle, most EVs would probably charge at about half that amount of time. I've got a big truck. So if you wanted level 3, which is DC high-speed charging, that is a very, very expensive mechanism that's running that, and it runs directly off the main lines. It runs there's
Power grid.
There's literally a coolant line going in the hose that comes up. There's a coolant line running because they're running undersized wires. It's super high currents. It's incredible stuff, and the technology is new. There may be something accommodating that in the future. It's going to be expensive, and it's going to be a while. That's all I can say.
So what you just said is you don't want to put that on your house. You want to drive to it. Yeah, of course. Question.
So as you use your inverter, it obviously generates heat. So most inverters are enclosed in electrical panels, and normally you have a vent fan. So often they're from like an audio application with a temperature probe. What do you consider an acceptable temperature level inside an electrical panel?
That's a good question.
It's a
want
good
me to
question.
answer that? Or?
I don't know, you go ahead.
Oh yeah, he's looking at me. Okay, yeah. So the question was,
I can-
inverters are often installed in confined spaces that aren't ventilated well. What do you consider an acceptable temperature for the inverter inside of the space? That was the question. Yeah.
The whole compartment.
The whole compartment. Yeah. Well, there's context behind the question. So our inverters and many other inverters start derating at 75 degrees Fahrenheit. And that's not very warm. Out here, it's warmer than 75 right now. And if you've got it under the bunk in your camper and you don't have the AC on, that's an oven in there, right? So anytime you can keep it cooler, it's going to last longer. That goes with all electronics, including ours. All of the components inside of our inverter are designed for a 12-year design life. Our warranty on those is 5 years, by the way, so we're designing them for 12 years. I've seen many last much longer. But the main thing that I see with temperature is the inverter output power. So this comes to me as a phone call of my microwave worked last week and it doesn't work this week. Your inverter's definitely broken. It's under warranty. I want it overnighted and somebody's installing it tomorrow. Whoa, hold on a second. What's happening there is this derating. And I can show you this at the trailer if you want to come up and see me, because it's a question from you. But yeah, it derates. So it's like a linear line between 75 degrees and 140 degrees inside of our box. So that's not even ambient temperature.
Yep.
And somebody was saying, I was just chatting with somebody that says, hey man, this thing generates a lot of its own heat. So not only the ambient temperature that you're dealing with, but also it's generating its own heat. So if it's in a place where it's suffocated, I'm using the word suffocated, or not breathing well, think about your own breathing, something like that. So when you're labored, it's thinking the same way. It says, hey, I'm getting pretty hot. So the inverter output reduces dramatically. Let's say you started with a 2,000 watt inverter, yeah?
I was going to say, speaking of labored breathing, they also derate as you get higher in altitude.
Yeah,
They have
also
to-
altitude, yeah, that's a very good point.
The thinner the atmosphere, the lower the conductivity. And our system, unlike a lot of inverters, it's actually, ours are safe to use at any altitude. Our components automatically detect the temperatures internally and will protect themselves, so you can run them. We've got them at Mount Everest.
To answer your question,
Yeah.
what is my temperature? I would try to keep it below 75 if I could, because that's going to be the best life for it. You can go beyond that, and beyond that, it's up to you. What is acceptable for the D rating would be what I would answer that with. Am I able to run the loads that are critical to me? Am I able to keep my air conditioner on to be comfortable? Am I able to cook food to sustain life? Those are the types of things I'd be looking at. And where does that power drop off to, and where is the temperature at which that happens? And if you want to see that chart, come see me.
Yeah, I've got a...
This weather, and I have a ventilated cabinet.
You have a ventilated cabinet?
I'm seeing around 110,
110,
Yeah.
115.
I was just going to say 110 is about the maximum temperature I like to see the system at. And there's another aspect to this. You were talking about inverters and electrical panels being near each other. Often the batteries, ideally, going to be close to the inverter. The batteries lithium batteries don't really want to be above 110 degrees. It's the same thing. They lose their, they degrade and have more health issues as you get above 120. 115 is kind of that threshold. So I've built out a tour bus, and we tried to power this big system and have a balance of all these things. We had to build in a coolant system that was bringing in fresh air with the ventilation and running that through. The inverters were ducted to run the air out. So sometimes a lot can be considered to run a big power system in a small space. But I would say 110 is the desired max. The inverters, I've seen them go up to 150, but like you said, you're going to weaken your lifespan.
Yeah, you started with a 3,000 watt inverter, and now you have a 100 watt inverter. You can't do anything with it, right? So 110 is a good threshold for Mitchell. He's installed these for years before he started working for Victron. Questions in the back? Yes.
Yeah, since you've got heat coming off of the inverter, and I'm paying for propane or whatever to make hot water, is anyone working on trying to transfer the heat so it's usable heat for me and cooling down our system? Have you heard of anything like that happening?
The ambient heat from the inverter charger used to do something. No.
You need liquid cooling.
No, it's a fair question, but I'm not aware of any way to capture that. Are you?
Yeah. No, at this point, I'm not heard of anything like that. So we've got hydronic heat exchange systems that run the engine heater block, and then that exchanges liquid. That's probably the closest application I can think of. I don't know of any inverter systems that are capturing heat, not directly, but perhaps larger applications, you could indirectly, passively use that heat through the form of the air. But yeah, outside of that, I haven't heard of anything like that.
I think it would be challenging to capture that.
Yeah, of course, if you're running 98% efficiency, how much heat are you going to generate?
Well, the inverters aren't 98%.
Yeah.
Question in the back.
88% on the inverters.
Oh, okay.
Yeah.
That's okay.
But to my understanding, I've got a solar panel and alternator bringing power into my batteries.
Yeah.
Correct? Okay, from there, they're going into other accessories through a voltage regulator, and then they're going into an inverter to make it a 12 volt. A 12 volt, I have a plug-in, which is my 12 volt, right? So that's where my inverter is going. Is my inverter not working when I'm not using that? Like I turn it off, do I not need to worry about an inverter at that time? Am I following the scheme slightly?
You want to repeat the question first?
Yeah. So essentially, I think the question there is that let's see. So is the inverter? What's the inverter doing? How's the 12 volt power coming? You're talking about the alternator, solar. We've got DC energy coming into the system. That goes into the battery, which is at 12 volts. And that goes into the inverter and generates 120 volts on the output of the inverter. The real question, I think, is do we need to keep the inverter on? And
The only inverter is the socket, correct?
yeah, the outlets.
Fan and the air conditioner is going through a voltage
So yeah, so how is I kind of simplify that to how is the inverter powering the system, and what components are supplied, what air conditioner. So a quick breakdown of all this: the inverter does not need to be on all the time, and whenever you're not using your AC loads, I'd recommend turning it off. AC being your 120 volt loads. So there's the DC outlets, which are kind of like the cigarette lighters, right? The circular ones. That's 12 volt, and then your AC sockets outlets are going to be the 3-prong. That is essentially, you could break it down to say, if you don't need a 3-prong plug, you don't need your inverter on. Put it simply, with the exception of the air conditioner and other built-in components. Water heaters can run on both DC, AC. Refrigerators can run on both DC and AC. So there's things that can do both, and preferably you probably want to run it on DC if you can, because if you're running a fridge on AC with an inverter, you're losing energy efficiency at each step.
Yeah, 10% to heat.
Yeah.
What we were just talking about.
But does that kind of answer the question?
I guess my question is, if I turn the inverter off, is it off, or is it still going to
Who manufactures it?
Oh,
I can tell you who the build that.
Is it blue?
I don't know.
Okay. Well, generally when it's off, it's off. But Mitchell likes to get into these weeds. But if it's not from Victron, it's hard to answer.
Yeah, it
Professional person, I don't know.
Just one second.
Your kids are back behind stuff, so.
Yeah. But generally, when you switch it off, it's off, right?
yeah,
Nothing's
it should
not-
stop consuming energy when it's off, and
Yeah.
and you're
Yeah.
exactly.
Notice heat coming out of the cabinet.
Yeah, and that's a good point. So heat, if you do run your inverter, it's going to be generating heat. One thing to mention, inverters have a zero load consumption, meaning they're consuming energy even if you don't run any loads. So they're producing heat even if you're not using them. So there are different ways to overcome this with surge watts and pulse width. We basically can turn the AC down to just blipping the AC every 60 cycle or twice a second, and the system will detect if there's an AC load. And in that, the inverter sits at a much more efficient idle. That's not the best thing to do if you have sensitive electronics, though, because you want to keep 120 volts on or off to make sure that those electronics are safe. So just a little bit, more.
I think the best way to answer that question is if you don't need any 3-prong loads, turn it off.
Yeah.
And you had a question. Oh, I'm getting to you.
Shocked.
You're getting shocked?
Yeah, like little sparks.
Oh boy.
Yeah, is there
Grounding.
something going on?
Grounding.
issues.
Yeah, that
How do I
grounding
do
out there.
that? What do I do?
Find a good technician.
I would find an installer. And I would.
It's
I
a
would.
rental. I'm sorry.
It's a rental.
Let me refresh that. It's a rental. We have it for the weekend, and I'm getting
You have a rental.
Take a video of you getting shocked and then send it to the rental agency.
Not-
Don't miss this opportunity.
Yeah, well, that's unsafe.
No, it's just, I switched off the little couch. You got all the dust.
Are you
off of
sure
it,
it's not
and
just
it's
static
like
electricity?
Yeah, static. That's what I'm saying.
Yeah.
Well,
I don't
that's
know. Could be.
I think it's just dry.
Static.
There's a
The-
good- I think if you had a real safety issue, you would know it.
Okay.
I'd say when you do have a hot skin, if you have electrical ground issues, the way I found out last time was barefoot in the rain, stepping from the ground onto the metal
Oh
step.
yeah, you lick your fingers
thankfully,
first.
Oh,
yeah.
If it's ground leakage, it's just an exciting little zap. But if it's a full 120, it's gonna
You'll know that.
really exciting.
There was a question in the back. Where are we located? Where do we live? Or where's the
grounding
trailer?
needs to be connected.
Oh, I live in
If you want
Maine.
to come up, we can.
He lives in
give you
Oregon.
instructions on it.
And the trailer, if you look at that white dome and take a direct right up the hill,
but
that's where we
it
are.
could just be static.
Come see us if you want to. Question?
Yeah.
Would a small fan be valuable in that component space to decrease the?
Absolutely. Cooling is always welcome with electronics. It does nothing but good for them. Question?
I think I have a Victron, and it's a little panel on a box on a new RV that I just got.
Okay.
And it has a dial on it. How do I know how to set the
I gotta keep
dial?
repeating the questions. Yes, you have a question or you want me to be louder about the questions? Okay, all right, let me repeat the question over here. I keep forgetting to do that. Give me a hard time about that so I remember. Thank you. You just bought an RV and it came with Victron in it and it has a panel, a control panel. It's a
Yep.
rectangle. It looks
Yep.
like this. Yeah, okay. It's a digital multi-control
On,
probably.
Or there's a third one.
Yeah,
Yep.
it's got a 3-position
That's
switch,
it.
some LEDs, and a knob. Yeah.
Yeah, what should that knob
What
do?
does the knob do? So this is Mitchell's
Yeah,
AC
coming back.
input
So
current.
this is the
limiter.
current limiter that I was talking about earlier. So when you get to a new AC power source, as you're plugging in, check the breaker size. If it's a 15, that knob should be set to 15 amps. If it's a 30, it should be set to 30 amps. And when you match that, it allows your system to utilize as much power coming from that power source without popping the breaker. You're not going to have power go out on you.
The one other thing I see here with this is somebody says, well, the breaker was 15 amps. I put it at 14 to be safe. You don't have to do that. You can put it at 15. The unit automatically lowers it a little bit underneath that. Its first priority is not to overload the breaker that's feeding it. So it's okay to put it at the rating.
Yeah.
Find where that breaker is.
Well, it's in the pedestal.
Yeah, when you plug in, I mean, if you plug into a 3-prong 15, that's the regular outlet like you have at your house. That's always 15.
No.
The bigger one is with its.
I think the question is, where is this breaker? Which breaker are you looking at, right? It's the
Then
pedestal.
I have to set the amps to.
Yes.
Yeah. How do you locate the
in
breaker
the
size
pedestal.
for your power source?
This thing was just gifted.
That's okay. That's why we're answering the questions.
Yeah, no
But
worries.
this part is outside of the RV, what we're discussing. So when you pull into the campground, you've got a power pedestal.
Oh, yep.
On that pedestal, most likely you have a weatherproof cover over the electrical connection. You flip that up, and you'll see the rating, the amperage rating on the breaker. If it says 15, you go inside, put your knob to 15. If it says 30, you go inside, put your knob to 30.
Got it. That's simple enough.
Yeah.
I can follow that.
You've been waiting a while in the back, sir.
Yeah, I think I now have two questions. But the first one, going back to your three-prong plugs, you said when you don't use a three-prong plug, you can turn your inverter off. Is that also true when you use shore power? If you have it on, will the shore power not go to your outlets?
Yeah, I'm going to repeat the question for the folks over here. Yeah. So we were discussing earlier, if you don't need any 3-prong loads, that's 120 volts for most of us here, is it okay to shut the inverter off? Yes, that's fine to do. But your question is an inverter charger question, I guess, right? So with the inverter charger, when you plug in your shore power cord, the AC feeds through the unit from its input to its output into your outlets inside of the van. Does that transfer happen if it's off, is the question. From Victron, no, it does not. So if you switch it off, you don't get any feed through.
The charger.
Charge, or you have charge only? Or
Yes. It has to be on the on position or the charger only mode for it to pass through from the input to the output. Because there's a lot of stuff that we're controlling there. We don't want that just flowing through there. So let's say you used a 3 kilowatt inverter charger. Well, that's pretty popular here. I've seen them in the rigs. That is a 50 amp transfer switch. But if your wiring's only capable of handling 20 amps, let's say, you don't want 50 amp uncontrolled flowing through there. You'll have wires on fire, or breakers blown at least. So with the amount of control that we do with that, we do not allow pass through the unit when it's off. And there was a follow-up, or?
Yeah, this goes to the 15 versus 30. When we've had our generator running, I can't use 15 or I can't use 30 because it seems to choke the generator. So there's another number.
Oh, this is a good question. Yeah,
This
so
is a great question.
when I'm using my generator, can the current limiter be used to a small Honda like the EU 2200's, a small
We
generator?
weren't using names.
Oh, sorry. Oops. You could use any small generator, generic brand name. And basically, these generators can't run an air conditioner typically, but you can use our system with the current limiter and run an air conditioner. I always recommend putting in some kind of start capacitor in your air conditioner as well for this.
Yeah.
But our system allows you to use a lot more power than what you typically could from a small generator.
Let's be very careful about the ratings on these suitcase generators. I call them suitcase generators. And, well, the brand, which we may or may not have mentioned here. When you look at these, it'll say like 2000, but it's actually not a 2000. If you dig into that, because I've been down this road several thousand times over the last couple of decades, it's not a 2000, it's a 1400, right? So be very careful about what it says on it. Generator manufacturers are very good at embellishing what those will do. That's a peak, that's not running, it's marketing, exactly. And I'm not saying anything negative about generator manufacturers because of course they want to sell their stuff, and so do we. But when you look at the number on the side of the box, that's not what it is. You actually have to go look in the fine print to see what it is. Because I've looked this up myself when I was digging in the weeds, try to help a client. And I think it was 1400 when it said 2200 watts on the outside of it or 2000 watts on the outside of it. So just be careful of what it actually does. That's just peak is what they're telling you on the side of the box, not what it can actually do continuously.
Yeah, 2000 when it breaks.
Yeah, 2000 when it breaks, yeah. Yeah, question?
I saw a YouTube blogger recommend checking the power source
really necessary with the technology today and surge protection?
Is it necessary? For us, no. So for inverter chargers, for instance, we have an input voltage range of 94 to 138 volts. So for us, it's fine. We have this huge window. Nobody else, no other color box, had somebody mention another color box, can do that, by the way. Technical reason to buy a Victron. For us, it doesn't matter. What you should be worried about, or what I would be worried about to answer this question, is my loads, my AC loads. Are they okay with having low voltage? Are they okay with having high voltage? In campgrounds, you'll get that, right? So you have a transformer when you go down into it. There it's 120 volts, but by the time you get down in the cul-de-sac in the back, it's 104 volts. Well, we're fine with that, but are your loads okay with that? That's how I would answer it. Maybe you have something to add?
Absolutely. No, just to add on to that, our system also offers a function called UPS, uninterrupted power supply. It's an added feature you can turn on, which not everybody wants this because it does create more AC interruptions because it's going to analyze the incoming power and act as a monitor.
Filter.
It's a filter, right? So it's not going to prevent you from getting a lightning strike effect. You're still going to have surge potential, but it's going to protect you from weak AC power, over voltage, frequency issues, and all that. Our system will naturally do that, but UPS adds an extra security layer on top of that.
And the wide window that I mentioned, so when I said 94 to 138 volts is our window for input, you can also close that window. So a lot of people use it as a filter and say, okay, well, I'm going to close it from 94 to 100, or I'm going to put it up to 105. So you have 105 between 105 and 120, or 125. So you can say, I want a very small window coming into my installation, and it will just reject the rest of it and invert instead.
But our standard settings come in very safe for typical electronics. You're not going to have to worry about any outlets.
Yeah, most modern electronics are okay with that.
And we're just about out of time, so we're going to do a couple more questions and finish up here. But yeah.
Got a quick one. To shut off your inverter, your 120 volt outlets turn off. If that's where your USB power comes from to charge your phone, you won't have your phone charging.
That's a good point.
One thing that you got to remember.
It's usually 12 volts though, USB charging?
So, well, yeah, so the outlets, a lot of outlets.
120 volt outlets that have USB sockets in them.
I got you. I got you. So the question, or essentially the statement, is that outlets that power your AC also have often a little DC outlet. Sometimes your RV isn't going to have true DC outlets. It's going to have them running off of AC. Typically, there's going to be a few DC outlets. So when you turn off your inverter, you might lose your USB port power. If it is built into an outlet, that will be the case.
Yeah. And there was one question here.
Yeah, we have three of them.
Match your products and other companies?
Yes, you can.
Yes, you can mix and match your products.
You can mix
absolutely.
and match. A lot of manufacturers do that.
In fact, a lot of people use our equipment with other batteries. Our batteries are
I will
excellent,
make
but,
a statement to this. And yes, I work for Victron, so I'd prefer that you buy all blue. But I've seen endless, I'm going to say it one word, endless problems of trying, in some cases, to mix different colored boxes together. I, personally, if I weren't working for Victron and I wanted to go buy a green box or a purple box or a pink box, I would buy all those boxes from the same place. I'm calling one place if there's a problem. Because I'm often confronted with a problem and I'm like, I am so sorry, but I can't help you with this. Just because we have a blue box in there, I can't help you because something else is going on. So that's the honest truth, and I hope everybody hears this. Yes, you probably have a mix of equipment in your installation, which is totally fine in some cases, but in others, it creates problems that we can't solve for you.
Matter of fact, you'll say it's your fault.
Yeah, well, it's not even this, right? So I get into this a lot, the pointing fingers thing. I don't do the pointing fingers thing. I tell you exactly what is happening and whether I can or can't help you and why, right? So it's not like, okay, well, it's his fault. No, it's his fault. Well, okay, well, this is exactly what's happening, and this is why I can't help you, or I can help you. That's where I go with it. Maybe we have time for any more questions. We got to get out of here. All right, thank you guys very much.